Right, we're going to begin Chapter 4 in the Civil 3D Drafting Design class, modeling existing terrain using surfaces. A key Civil 3D object will be our existing terrain vis-a-vis Civil 3D objects named surfaces. In the last chapter, we ended a little bit some issues using a lot of associated files that are no longer valid in Civil 3D version 2020 and above. This chapter, we shouldn't have much of those issues anymore. I'm going to be using Civil 3D 2022 just to see how it fits with this older text. My space will look a lot darker, possibly if you're in 2020. We're going to start on page 65 here. And in Revit, or excuse me, Civil 3D, make sure you download your files here, which are going to look essentially like this, minus this folder, which is just for me here. You're going to have the complete version so you can check your work as you go, but I want you to turn in all 8 of these until otherwise noted for your full lab credit into Moodle right here. And your due date is shown. So let's jump into this chapter. So the four main things we're going to learn is what is in the surface and the main things to create them, a few things anyway, not every possible thing. How to use break lines will be one main part of that. This is kind of a two-parter of the first area. Then the second main area is how to edit surfaces. And what I mean by edit surfaces is editing operations of data inside of surfaces. And there's several things which we'll learn on that. The third area will be displaying different surface styles and changing how a style looks and analyzing surfaces visually in different ways. The last area we're going to learn a little bit of annotating surface with Civil 3D objects. So with that, we'll go into the first page talking about surfaces. They're known as in AutoCAD as a triangular irregular network, a TIN algorithm. A TIN consists of essentially lines and points. And going with the text here by Chappell, we learn, and something I've learned in industry very well is most surfaces, they have, let's say, 1,000 points. They generally have about 2,000 plus tin lines, about 2 tin lines per point. And each tin line can go usually almost always one of two ways, almost always. So you can move, the tin lines are smart to move a certain way. The algorithm isn't smart enough to always know exactly which of the two ways a tin line should go, so there has to be some manual edits. We'll find out with swapping triangles. It's not 100% smart how to do that, and that's the same with existing surfaces and design surfaces. Existing surfaces tend to have more wild-looking, random-looking tins, especially in the lines connecting the points and the lines essentially together, because they're not as uniform of surfaces. They're more natural looking. They're not as man-made and rigid looking, which will also be doing surfaces of a design nature. Existing surfaces are very similar to design ones, but existing ones tend to look a little more irregular for sure in the tin. It's a little more emphasized on the irregular because they have natural forms, not man-made. So we're going to start by going into 4.1 and get the file open, create an EG surface DWG, which I'll go right into, and we're going to learn about right-clicking, going into tool space on our next area of surfaces, and starting to add data to them. And if you see this, EG stands for existing ground. That's pretty standard. A lot of people like to say that in industry for shorthand. So, of all the stuff we learned in Chapter 3, all the COGO points, you learned about COGO point styles, how they look, how their labels look, also how to import them, which is the second main thing from Chapter 3. And the third main thing was how to add extra COGO points. We learned a little bit about adding new custom ones. We're going to take a lot of what we learned in those raw points and bring them to a surface in this chapter. We'll learn about the definition, the contents available in a surface within tool space, surfaces, and definition. So let's start up with that on page 67. I'm going to go into create an EG surface. I got all my files ready here, and we're going to break right into that area. And in Prospects, we're going to begin by going to Surfaces, right-clicking and saying Create Surface. And right now, it wants us to do a various amount of things. We're just going to call this surface in the name box EG in caps, and we're going to pick the surface style of C, existing contours 1 foot, 1 foot intervals. So 1 foot minor contours, 5 foot major contours. We're going to select that, and we're going to continue on by hitting OK. And in the prospector, our surface is now populated. Nothing in it yet. Coming into the definitions here, and we're going to begin with that. So the components of a surface real quick into 68 and 69. I'm not going to go through all of them, but the key ones we're going to learn about are boundaries, break lines, drawing objects a little bit I'll touch on. Basically AutoCAD objects like lines, AutoCAD points, text even, and various things, especially if it has Z dimension or elevations. Edits is the next big one. Point files I'll touch on briefly. Basically an external type file linked somewhere else in your Windows Explorer or your data files that syncs with the surface. For example, I use for LiDAR or very complex maps, hundreds and thousands of points from a point file with just an X, Y, and Z. It's just filled with basically ground points that an algorithm spit out for me that I link to my surface. We're not going to do that in this chapter. In this introductory, point groups is another one. That's a big one. Internally to this drawing, a certain point group, which we learned a bit about in 3.6 was the big part of chapter 3. And we'll add an entire point group. A lot of times ground shots is that particular point group in that case. We won't be doing much with survey inquiries in this book. That's a deeper dive into your survey database, saying we want this survey figure and this survey question asked and pulled out. We won't be diving into those. Contours, very similar, elevated polylines that basically map our surface exactly how those polylines look. So it forces our tin to align with these contours. They have to be elevated, so each polyline or 3D poly, they have to have an elevation inside of them. Otherwise, this doesn't really work. DEM files is another type of file. It's a raster type file. Digital elevation model. It's pixelated. I believe if you look up DEM files or surface, it's a digital elevation model. It represents topographic surfaces. It's just a different way of representing a surface. It's a raster type surface instead of a tin, which is more vector based. So that's some surface data we can add, which we won't in this chapter. So let's begin by adding some of this stuff now that I've talked about what can be in a surface, typically anyway, and the definitions in Civil 3D. Let's start by right-clicking point groups and saying add. Let's add a point group, and it wants us to add, I like to expand these if I have a lot of them. I'll add, in this case, in step 7, ground shots only. And give it a second, our surface now populates. You can see contours. They have a certain look to them. This is the existing contour. All these ground shots the surveyors mapped out in the field have become real. And most times when you're mapping, you won't be doing it in this view. This is nice. This is zoomed in. A lot of our files come in this 3-panel structure. I might go, like in chapter 3, to 1 to speed up my computer. We're going to mess around with these different 3D views a little bit and renderings in your upper left. But mostly we're going to stay in top 2D wireframe most of the time. So we'll touch on with that later. Now, I can turn that on, for example, to something different here. You almost have to switch around to a different angle to see that one. So that's the picture on page 70. It's in Southwest isometric 3D view and conceptual type rendering. We could do some shaded renderings. The surface has relief, but it's a little hard to see if it's not really very, how do you say, vertical relief, a lot of elevation change. So let's go back to top and 2D wireframe. So that's what this one's in, as you can see already here. So goes into, that's about it for the first file. Now, while I'm talking, I'm going to go to the second file, add break lines, and we're about to add, in this case, they could be 3D polylines, or I've said feature lines are much more common in industries I've worked at. Unless you're using the full extensive survey database, I select these entities. I'm going to leave my properties sitting out here. I'm going to cascade back my tool space just so I can see what I have selected. Okay, I don't really like how those sit out there. Give me just a second. Pause this. There, I have things the more the way I want it. I want my properties to stay on. I like that a lot of times so I can see what I select. All its various attributes come up. I like my tool space hidden. Sometimes I'll leave it turned on and wedged in, or auto hide turned off when I need it for quite a frequent amount of time. My tool palettes, which we'll get into later chapters, different assemblies I like to drag in, and I leave on this side. And my design center, which is moving around AutoCAD styles from drawing to drawing, I like to leave too. I don't use that one quite as much. But in general, I've gone towards the user interface of everything on one screen as much as possible, especially the more I work remote. I've been finding that advantageous and just being very surgical with my screen real estate on my most frequent 5 or 6 palettes I use: external references, layers, sheet sets, tool palettes, design center, tool space, of course, for Civil 3D, and not least important, possibly most important, my properties. So back to in my command bar here. I like to leave on, as I've touched on in chapter 1. Anyway, I'm back to where I want to be. Let's talk about break lines. So the picture on page 71 is very critical. This really describes the difference between break lines. They come in, they're very key features in terrain, whether it be design or existing surface, and it's where the surface tins and the triangulated irregular network breaks. They're forced to do a certain direction. And this is quite literally a very good definition of a ditch, an uphill slope, and a road. What it would look like without these break lines added to the surface, and this is what it would look like with them. It defines features linearly a lot better. This is an existing road, most likely by the looks, and a forced alignment of tin lines along a linear feature is best handled with a break line. A break line forces the tin to break in a very specific way to make a channel, a resulting look, and we'll go through that in a minute. It improves the surface accuracy, like it says here in the book, is one of its general takeaways. So we're going to learn to add those here. I'm not going to touch too much. We're going to attempt to use it with the survey figure database to add break lines this way. This may not work since I'm in Civil 3D 2022. If it doesn't, I will move on. It's not the most important thing. We can add break lines through survey figures as well, which is more what figure 4.8 is showing. We'll give that a shot. If need be, I'll pause the video and try it in 2019, where I know the survey database file, as we had problems in chapter 3, should work if I have time. So let's start with exercise 4.2 and add some break lines. Wrong one. And I'm going to begin by trying the survey database way. Okay, let's see how this goes. Okay, so what's going to happen on exercise 4.2? That is not going to work. It's going to be a similar error. I can walk you through this for extra credit, which I will. It's having issues linking to the line work code set and the figure prefix database somewhat. So what you could do, if you want to do 4.2 exactly like the book, you could go into your survey database setting. Let's pretend we didn't see all this stuff here. For now, this is me basically getting these to be found. You might already have this done in your Civil 3D 2020, 2021, or 2022. So these are the three versions that aren't jiving. You need to link the survey database defaults file here. We don't really need to look at the equipment defaults. Three files, or three linkages basically, need to be in place. And we'll go over them right here. This path, survey database default, line work processing default, and figure default. And you need to have these options showing. Now I went to my home base, my Windows Explorer. You have to link to this path wherever your chapter 3 all your lab files are. You have to link to all these files. You're trying to get it to link essentially to these 6 files. Wherever you have these 6 files from chapter 3, that's what you're pathing to. Okay, so wherever you put those, path here, here, and here. Hit OK. They should now show up here in your figure prefix database line work code set. You might have already bumbled through and done this from chapter 3 and got it to work. These do work. The survey databases do not from chapter 3, as we found out. So what you need to do this roundabout thing, and I'll show you the quicker way after this on 4.2, which I would recommend potentially, but these are survey figures, so I'm just curious if it will work. I'll test it out before I do it. You won't have this here. So in order to add survey figures the way they want to in 4.2, you need to have them populated in the figures and the survey points in the survey database, which is this. I just called it test 1. What I did, these will all be blank. I've already done this. I couldn't undo it once I tested it. You have to import survey data, pretend this stuff's not there. This is just me doing it again. Call it whatever. I just started, or excuse me, before that, you need to go into here. We could try this again. We'll say set working folder. Set it to your chapter 4 lab files essential folder. This is hopefully the last time we have to do this. This is good training. Set it to this folder, your chapter 4 lab files, which I did. I said there. Let's do a new one for you so you can see what I did again. Let's say video example. So select that as my folder. Okay, that I have to restart this now. I have it set. Now I got to create a new survey. I'll go a little slower. I've set it. Now I'm going to create a new local survey database. I'm going to call this Aaron1. Call it whatever you want. This is just so they're distinguished different. So see, I went to chapter 4 lab files. I made the file, I set this as my working folder, wherever folder it is, and I call it Aaron1. It creates new files. These are the new survey database files. There's more of them. There's SQL files and various other things. So wherever you do, make this somewhere in your chapter 4 files. It goes a couple deep. I just call it video example. Put it in within your chapter 4 files, call it wherever you want, and when you do this step right here, it creates this folder. So that, one last time, go set working folder first, set it to where you want, and then the second step, name it to something. New local survey database, name it the folder name here, and it will create this folder underneath the original folder you made here. When you set this working folder, it'll create this folder that you just created, new folder, through this option. Really confusing, but this is the last time we're going to see it. This is good learning if you ever use a survey database. Now it's blank. This is like me starting over again. This is to get 4.2 to work. Keep in mind, I need my figures in here. and also my survey points, but most of my figures. I'm going to add them as break lines, this weird roundabout way, which I don't really like, and I'll show you the easier way after this. We got to go then to import survey data, or we could say import points from drawing. Better yet. And there's already 715 points in here. Let's say it's the default with the carets there. We'll accept that. We want all of them. We'll say enter. This is key. This is going to bring in survey figures, but we need this to be showing. So if you have sample showing, you need essential showing. That's key here. Same with the line work code set. These two need to be the ones queued up. Also, yes to this. Process line work. These three are the biggies. Okay, it's going to go for a minute importing the points and processing the line work into the survey database. Give it a second, let the wheel spin. Now your figures are populated here and your survey points are populated here, separate from your COGO points. Let's expand this for purposes of showing this. So that's the roundabout way, which I really don't like, since our survey database files aren't compatible. Yay, surprise again, that happened. Hopefully that's the last time this happens, but don't hold your breath. Let's expand this and say create break lines. This is all the work I did just to get to step 5. I'm going to take all these survey figures. So keep in mind here, see how these come in the survey database? They're here as physical objects too, keep in mind. These same survey figures. So I click on it, it says it's a survey figure. They're also here, okay? But the key is they have to be in the survey database. That's why I went through all that rigmarole. Mind how some of them are called break lines and some are not. So this is good time to talk about break lines. Like the ones that are not are just 2D features, like a fence or an edge of tree or something or another. The other ones are going to be in the surface as break lines. It's 3D lines, and it's saying as such. So some you can see edge of shrub, tree line, those are not. So that was brought into the survey database too. So let me right click and say create break lines. You're going to see which ones are and aren't again. And these are the ones that are going to create. Just take a look, note which ones are break lines, which ones aren't. We'll do this all at once. This actually, if you have your survey database brought up well and all your figures are looking good, like they're cleaned up decently well and in the right orientation, this can be a pretty quick way to bring them to the surface. Otherwise, you have to manually select them, which I'm pretty fast, and I'll show you that in step 2. Oop, I've got to select a surface, huh? I'm in the wrong drawing. Add break lines drawing. Okay, now that I'm in the right drawing, let's do that again. My survey database is still open even though I switched drawings to my add break lines drawing. Just note that. That could happen to you easy enough, but we'll do this again. Right click, create break lines from all the survey figures. It still pulls them. This is the one I actually created the surface in. Like I said, this is the long way. But if your survey database is dialed in all the settings I just showed, it's not too bad. They're all adding now. Only the ones that have yes next to them are adding. This is good learning if you take this step up a notch. Definitely give you extra consideration on your points. Now, this is going to come up no matter how you add break lines, whether you do it the roundabout long way through survey database or you add them by adding feature lines or 3D polylines, which I'll show you next. This still comes up. So I'm going to say in here, I like to say what I did. All EG site brake lines. This is important. I'll leave this as standard, and we're going to call the mid-ordinate distance. This is how much it triangulates on curves. This distance, if we wanted to change it, this is how much it triangulates extra in between node to node. So say this is 100 feet here to here, and you put 10 feet here, or 19 feet, it would triangulate 19 feet, 19 feet, 19 feet, 19 feet, everything in between 19 feet. It adds more triangles. I'm going to keep this as 100 because that's what it wants. This also triangulates tighter when there's ever a curved survey figure. That's what we're doing. We'll hit OK. Let the brake lines process, and they're added to the surface. So here we finally got there. Let's do an undo. See, watch how the surface changes. Hopefully. And redo, Control Y. See how my surface, these brake lines really define ditches, tops, and slopes. Especially you can see this ditch. It V'd it down. So they're breaking the surface to its, they're making the tin break to its will and form the way the ground should. So that's one way of adding to the surface. I'll show you another way here in a second. Let me just prep a drawing so I can show you the possible much quicker way, which I'll probably have you guys do on quizzes and tests. All right, back to it. I will instruct, and hopefully in the email, so before you open this whole video, you've skipped to this part possibly. Another way to add these brake lines even quicker, I did a save as and said add brake lines file 2, pretending I didn't do it the way through the survey database that we just showed, going through here and adding brake lines this way, various things. We're going to do it the quicker way, in my opinion. Depends on the site. Complex enough site, if your survey database was dialed in, that's a quick way to add all the brake lines. Right now, you have to select them in some way or another. I'm going to start right-clicking and doing my old friend select similar. We can also use quick select, which is a deep way to select many things. Let's try that actually. After we do select similar. Select similar, you have to have like things selected. I have pretty much every brake line selected already. By the looks, you got to be wise enough not to select the things that aren't brake lines. These are not. Okay? These buildings are. These fences are not. So this is where a little bit of intuition is needed. Now, it didn't just do it automatically for us, like it said brake lines yes and no in the survey database. This needs a little discretion. So I didn't select the ones that won't be in the surface, like the fence and the tree lines. Now I simply just take all I selected. Quick select wouldn't work for this. I would have said quick select, grab all survey figures, which would have been incorrect because I don't want to grab this survey figure, for example, this tree bush line. I don't want it in my surface. It's not a true brake line breaking the surface. So what I just did by picking manually and saying select similar, as I accumulated them, just keep selecting more and right-clicking select similar and building your selection set. Don't lose what you pick. That's the slow part. Now that I haven't picked, if there were feature lines, I could right-click and add to surface. But we have to do this trick. Close attention here. Go to tool space. Let's get out of survey database, hopefully for a while. Let's go to surface, the EG surface we made. We're going to add these brake lines this way. Click on the left click. Now right click, say add all brake lines. Let's call these. Now let's redo this step. This is the easier way in my opinion. The brake lines will function in a second, and voila, those survey figures are now in the surface. The same way but easier. In the same coin, if I came in, a lot of times we'll do this out of industry, is I grab all my survey figures, I blow them up right away. I change them to 3D polylines and leave them in there, or I change them from 3D polylines into feature lines, and I use them that way as break lines. I get rid of these survey figures because they're kind of unwieldy to edit later on to change symbology and various things. So I did already add them to the surface, but a lot of times initially I'll grab them, hit X for explode. I'll explode all of them. So they're already defined in my surface, so that's going to update my surface. Usually I didn't do that part first, so it goes back to being a dumb surface without break lines. So let's say third option to add these break lines. They all come in as survey figures. I just exploded all of them, as you just saw. Now they're called what you call 3D polylines. You can add these to a surface, or you can change these 3D polylines into feature lines. Create feature lines from these objects. Adding feature lines works as well as 3D polylines. They both are perfectly great options to add to an existing feature surface. Now I like feature lines a little bit more. They're unwieldy. Feature lines are far superior for doing design surfaces because they can be edited in the horizontal and vertical far easier. 3D polylines not so bad because theoretically when you have a map it should be very close to what it exists in the world, so you don't want to edit it too much theoretically if the survey data is good. So let's just grab all these 3D polylines and do a similar kind of maneuver. Grab what we think is all of them, say select similar. Looks like I got all of them. This takes a little bit of surgicalness to it, which is part of the difficulty on bigger sites, but you don't have to deal with the unwieldy survey database. I have them pretty much all selected. I take a look at my selection set here. They're all 3D polylines, which is great. I don't have my tree selected. I don't have my fence, which I don't want on my surface, and I can do the same thing as I did when they were survey figures. I can add them as break line in this existing ground surface this way. All break lines, but they are poly. It's just a note for you guys. I'll leave the same settings and hit OK. They'll add the surface in the same way. And it's not as unwieldy as dealing with the survey database. So there they go. They broke on the surface. And yeah, on the bottom of page 73, it's just explaining a little bit why we didn't add the fence and the edge of tree line, because they're not defining features of the surface. So we're going to continue on to page 74, which starts by saying what I already mentioned. You can see how these swales and these contours are now better formed because of these break lines we added. I showed you several ways how to add them straight from the survey database, directly by just grabbing or the second way without the survey database, just selecting similar by grabbing all the survey figures that you could in one selection set and then adding them. And step 3, blowing up survey figures, which a lot of times people do. Change them to 3D polylines, which they are initially, or feature lines, select them all again, add them to the surface break lines. 3 or 4 ways to do this. I prefer adding them as feature lines or 3D polys. They're much easier to edit later, which you're always going to have to do. So I highly disagree with the book's method on this, but I do like how they show you the power of using survey figures if need be. So in the top right viewport, it says, let's click one of the surface contours. And we have our tin surface. We can see some of our definition in the properties and our options on the ribbon and the contextual ribbon. The things you can do with the surface come up here in the ribbon. Options of its Civil 3D style, its layer, its symbology here, number of points, max and min elevation. A lot of stuff come up. Take a look at some of that. Now, it wants us to go into surface properties, which you can go this way. Up here in the contextual ribbon, once the surface selected, or you can right click and go to surface properties here as well once the surface is selected, there's a couple ways, or you can go through tool space and right click and go to these same areas. There's generally 2 or 3 ways to get to the properties of a Civil 3D object, and that's just an example of it on the surface. It wants us to go to the Information tab of Surface Properties, and it wants us to change the surface style to triangles. And wants us to hit OK. And my surface is probably still selected. No, it's not. That's good. So I'm just showing you this style, visual style of how the surface, I'll activate this viewport, you can see in blue, is now a different appearance. You can see it's made up of the tin lines in blue and the surface points actually not showing. So the tin lines meet where the surface points are, but they're also corresponding to where the Kogo points are. So in a tin surface, there's points in the tin surface that are independent of the Kogo points. They act together a lot of times to form the surface data, but they are 2 separate things. So let's select the surface and right click, go to Surface Properties, or we can go up here to Surface Properties, and our dialog box will come up. And now it wants us to go to the Properties tab again, or the Definition tab in this case, and it says we can turn off certain operations. So we've added these break lines, but let's just say these operations will populate and there'll be many of them. You can turn them off temporarily here, and it wants us to do that. Hit OK. Yes to rebuild the surface. It takes out those break lines. As you can see, it stops triangulating and forcing the tin triangles to break on them. It goes right through them, which we don't want. But that's a pretty cool way actually to remove a edit operation or definition of a surface temporarily. So you can go back to Surface Properties through here or here and add it back. You don't have to delete it. Okay, so there's a couple ways. This is a way to do it temporarily. There's a way to take it away permanently in tool space. So I'm going to add them back here. I'm going to allow that. We turn it back on, and I'll hit OK. Yes, we want it to rebuild just once here. They'll retriangulate. Let's grab this surface and right click, and let's send it back. Sends it to the back of the display order. And default in AutoCAD, new things that are created get displayed in the front, the foremost, above everything else. That's just the default of AutoCAD. When you copy and paste something, that item will go to the front by default. So a lot of times we just made a new surface, it will go to the front. So you need to manually turn and send a lot of things to the back. So you can see that these re-break on here. Now, likewise with the surface, you can go into break lines similar to what we just did, but this is different. And to the definitions, you can also see it's here too. You can right click and delete this, but that will delete it permanently. It will be gone. Unlike when you might not want that. You might want to just see what it looks like temporarily, which we did here. So that was permanent. This is temporary. Big difference. So we'll hit cancel there. And that ends that area. We're going to move on to the next area in 4.3. So moving on to some more advanced topics into 75 and 76, you have different types of break lines. You have standard break lines, which 99% of the time that's what they are. They have to be some kind of 3D entity with 3D and 2D. They break along the 3D and 2D. And you have proximity break lines when this would be added. For example, let's just say add break line so we can see some of this stuff. So let's say adding a break line like we're doing it. These are the main two. Proximity break lines can be two-dimensional. So if this was a 2D polyline, it could be used as a break line too, but it needs to take proximate guess of what the elevations would be by the data around it, but it would force the triangles to break along it. So if you were lacking three-dimensional break lines exact, you could have 2D ones to simulate a, let's just say, a ditch or something. So we could see how one works here by drafting in a polyline. Let's just see what happens. I'm kind of curious. And I'm going to add a break line. Let me pick it here first, pre-select it, and add proximity test. Let's just say it's a proximity. Let's say OK. Adds that one break line. It breaks along it. So it changed the triangles, but it just guessed its best elevation in between all these Kogo points. So those aren't entirely accurate, but it's kind of cool to mess with those to attempt to caress your surface when you are lacking break line shot. I'd always usually recommend using ones with 3D features so it's more exact, and then proximity to what's data's next to it, it's approximating to. If I hit delete, that entity is now gone, but it's still lodged in my surface definitions, so I need to clear it out. I'm going to added it. Now I'm going to delete it out. I'm going to delete it from the surface. This means the surface needs updating with that rectangle. You can leave this on automatic and it automatically does it. I prefer to do it once in a while, so it's not always doing it. So I'll rebuild it back. That's gone. Now the same case in point, in some advanced topics on page 76. We can add break lines with some other features. I was talking about this one. You can tell it every 1 foot in between nodes it has to take a triangle. We could rerun it. We've already ran this once, and it might not work this way, but this is just saying every 1 foot. This is saying on the curves it has to go, let's say, every 1/10 of a foot along a curve. None of these are curved break lines, but if there were, it would form triangles. Tins all are only straight lines, so sometimes if there's a curve, an arc break line, you need to make it triangulate more on it to simulate a curved surface. So that did add it after the fact. I way overkill on the triangles. I added a triangle sampling every single foot. That's way overkill, so I have a ton more triangles. But really my only real data on that break line is here and here, so it's interpolating all in between. That's way overkill, but that was just an example to show you how I could do that. So I added, this break line's been added once with all of them in this data operation. Okay, up here you can see all the break lines that were added with how many vertices. They each have their own properties, all kinds of stuff. What was all added in the X, Y, and Z. This is me adding it again with just a bunch of vertices. I'm going to delete that out. That's some advanced stuff that actually a lot of people that know how to do surfaces pretty well don't even know how to use. That's how to better caress your data. If you don't have all the break lines you need, you can draw 2D ones you can basically manipulate the triangles how you want, but that takes a bit of practice. It's better just to have good survey data from the beginning to help you get an accurate surface. So we're going to move into the main part, number 2 of this chapter, editing surfaces. We're going to start by adding a boundary, and an exterior boundary you can do in a couple of ways. I just closed my files. You can add them, like I said, in a couple of ways. So basically, boundaries around surfaces are a way of defining where a surface is and where it isn't. At this point, we've included a lot of our data in the surface and break lines and points and various things. There's a lot more editing we can do to pretty up that surface, to put some lipstick on that pig. So we can, by starting this, we'll go to boundaries first. So sometimes a boundary is how you remove data, and sometimes it's how you put a boundary on at the beginning to suck in the data. There's a couple ways to do it, but your surface is all inside either way. So let's open up the surface boundaries drawing. And there's a couple main ones. We'll have our outer boundary where it says everything inside remains, and we have our height boundaries, is very common, where it says everything in this area should be voided out, and almost like a hole in the surface that we don't want data. And there's a couple other boundary options. One is on page 78 called the show boundary, and the data clip boundary is another one as well. I'll talk about those briefly. So those are here on page 78. So it says a show boundary creates an island of data within a hide boundary. So it's a small little island within a hide. Not very often, but you might have that. Let's say you have a huge area you want hidden, but there's a small little very important area for whatever reason you need to have shown in your tin surface. That is a small little courtyard inside of a footprint of a building. That is a great example. The data clip one I rarely use. The first three types of boundaries, it says hide the surface after it has been created. A data clip boundary is a special type of boundary that prevents data outside from ever becoming part of the surface. Data clip boundaries are used in cases where a small surface is made from source data that covers a large area. So those don't get used very often. They're basically saying you have a huge surface, miles of tin surface. You want it to clip down to a very small surface from the source data of huge amount, large area. That could be maybe a no-no. Sometimes you might want to just pare down your source data. So a lot of times with large surfaces like that, there's a lot of ways, and we won't go into it here, to keep your file size manageable and not so unwieldy big with large source data and LiDAR and stuff to clip it down. This might be one method to try, but there's many others. So we're going to move on to exercise 4.3 and add some boundaries. We already have the surface open, or the DWG file open, and we're going to click on one of the surface contours to get started. And we have our options in the contextual ribbon with our tin surface and the contextual ribbon open. We can edit surface data, but we're going to continue adding data. In this case, we're going to add a boundary. And it's going to come up. You can also pre-select the boundary and go to tool space and add them, but we did it this way. I'm going to say building 1 for this boundary. We're going to call this one a hide boundary. It's going to hide out this area of the surface. And we're going to have non-destructive break line on. In mid-ordinate, this would say how much triangulation in between. Hit OK. And it's now prompting us to select objects. Always watch your status bar or indoor command bar. It tells you what to do a lot. Just like in Revit we learned. Hit enter, or left data click, excuse me. Now hit enter. You should see a hole emerge in the surface in this 3D view to the lower right. It hid effectively this part of the surface out with that building I selected. It appears that the surface has been trimmed, but in reality the surface, really the data has just been removed within that shape of the building. It's still kind of in there in the ether, but it's voided out in that case. I'm going to jump ahead just one area and show you the difference of adding a boundary. I made this polyline just for quick effect to simulate an outer boundary. I've already done this step here, and I have it pre-selected. Instead of selecting the surface first, the Civil 3D object, and then adding data this way, the boundary, which I would select that, and then I'd select it. I can also have it pre-selected this way and go into tool space and say I changed the surface style to a different style with triangles and contours if you hadn't noticed, and I can add the boundary this way. There's one we already added here. You can see that populating in your definition of your surface. Let's call this one building 2 or just 2, and I'm going to call this one an outer boundary. And let's leave the non-destructive break line on. So let's see the difference. It cuts on that break line, or excuse me, this boundary. It'll take a second. It's thinking. Hopefully I don't crash. If you haven't crashed CAD in a day, like I said, you're not trying hard enough on that day. AutoCAD likes to crash. So it splashed up against this nicely. That's the way I would want it. Now, let's say I get sick of that. I'll show you the difference. Let's go into this operation boundary. I'm going to delete it out. Yeah, I want to permanently remove it. Let's add it in again. We can rebuild, sure, and just watch it come back. A lot of times, don't worry about Event Viewer. There's so much going on. Don't even bear to try to keep up with the errors on the events most of the time. Just some word for the wise for the most part on that. Let's add the boundary again. Let's pre-select it the other direction. Instead of selecting the surface first, let's add it again. This time, let's add it, yes, as an outer. Let's call it test 3 this time. Let's turn off the non-destructive and you'll see the difference. It takes a minute to retriangulate. It just kind of made some jagged edges, basically destroyed the edging of the surface. It didn't project it out around. So in general, we want to leave that non-destructive on. So it's non-destructive. Let's remove that and get back to the task at hand. Rebuild. I said ignore these errors most of the time if you have to go back and forth, especially undos and redos. Be very careful with major Civil 3D operations on some of these undoing and redoing. Do saves many times before you do undos. It's a very notorious area of crashing, and Civil 3D will hit that. We'll go back to where we started. Let's keep adding more hide boundaries. Okay. Let's select more of these buildings, basically. I'll do my best to get them all. If I miss a couple, there should be 7 total. We did 1 already. Should be at least, I believe, 6 more. 1, 2, 3, 4, 5, 6. You can also see here there's survey figures. I know I blew them up in the last one, but I've continued on this drawing. They've remained survey figures. We can right click and add them. I'm going to go about it this direction. The book says to select the surface first, then add them. You can go either way. We can call them remaining buildings, and they'll populate that way. We're going to say hide. We're going to kick back on what we messed up here. We're going to say we want it to be non-destructive. Hit OK. They're going to void out here. Give it a second. Now we have a bunch of little voids and neat little hides. So we're going to move on to deleting lines on page 79. Basically, this just involves deleting outlines of the surface, undesirable ones for whatever reason. We'll open the file, delete 10 lines. So there's a lot of reasons you might do that. You might have some, especially on the outside periphery of a surface, a lot of times I'll delete out odd triangulations where it tries to do too much. The book doesn't talk much about that. That's more of an advanced topic, but it is something you do a lot. So if I change the surface style properties to something I can see the tin better, let's change it to contours and triangles. This one's pretty well done, but right here, I'll delete out all these triangles right here. They're triangulated in a funny way that's not realistic. You get an eye for triangles as you go on, especially with existing undulating surfaces. This one looks okay. It's a flattish area. This one would be a little nitpicky, but I would delete this area of the surface out right here. Okay, that's some of the main triangles we're deleting out. You might delete out some triangles in the interior where there's some bad data. A lot of times I would do that by deleting out points. So if I click the surface, I would delete out add or modifies moving points elevation, adding a point, adds in a point in the surface, not a cocoa point. They're different things. They work together a lot, but moving a point moves it horizontally, modifying moves it vertically, deleting it deletes it out. I would probably use this in the interior a lot more. I use delete lines a lot on the exterior periphery of a surface. I add lines a lot of times when I want to form a ditch or make triangle tins go a certain direction that they're not already. And swapping edges we'll get into, it flips triangles around. So if I go to swap edge, this is a very common command. It'll move a tin triangle in one of two ways. Usually it has two ways to go. It has here or it has back here. So each tin basically has mostly the two directions to go, there or there. And they start to add up to form a picture though. And if it has nowhere else to go, it'll tell you that warning you just saw. So it helps pretty up a surface. You can go really overboard with this if you want. But algorithm's not always smart enough to do this part on its own. You need to smooth out the contours, sometimes manually, by swapping them one here. You can go or here. The algorithm gets them pretty good, but it doesn't get them all. So that's one surface method. As we go into deleting lines, I'm going to go and keep this surface on triangles. I'm going to leave the surface on triangles and contours, honestly, so you can better see how the contours are changing. I kind of like that better. So it's basically saying on figure 4.13, the extents of the surface, they offer, like I was just saying, after erroneous tin lines have been removed. So now that I have my surface style changed to something more favorable to see, I'm going to go select the surface, go to edit surface, delete line, and let's go into some of those. And you can cross box and delete multiple lines like this. You can do many operations at once that stack on each other. So I got a few going there. I don't want to do too many because I might make a mistake and I want to undo what I did. I got 3 different multi-line picks. I'm going to hit enter and just accept that for now. You can crossbox this direction, grab all of them. You can even pick one line at a time. And we're just going to delete out some of these erroneous lines. It's saying this is something you're going to do on almost every surface around the periphery. On a big, large LiDAR surface, I might actually draft a polyline around it first because of the unwieldy nature of retriangulating surfaces, and then I'll tell that that polyline to keep the surface boundary that's at the outer boundary. But these GPS shot surfaces, traditional surveys, I mostly just delete out the triangles along the periphery. That is the preferred method, industry method most of the time. Here's an erroneous one. We'll delete that out. There's some weird data going on in here. That would potentially need to take a further look, but I'll delete that out for now. And we deleted the outer triangles that we didn't like. So we're cleaning up the surface little by little, which moves us into 4.5, editing points. I almost want to just keep moving in this drawing file, but I'm going to go to the next one just to appease it and kind of so it follows through with their steps. And I just talked the edit point options, but we're going to go a little deeper how they work. So we see a point here that's triangulating down to a bad elevation. So remember, our surfaces are pretty much made up of points and triangles, and if we click on the surface and go back once again to change it to triangles and points, or you can also click on it. I like contours and triangles. You can change it here as well. Properties. You can see this erroneous area I noticed myself. It's pulling this point of the surface way down here. So click on the surface and go to modify point. So we want to basically modify the elevation. Oh, we have to have a surface style that has points on. Almost forgot about that. So if I click the surface one more time, we'll go this direction. Surface properties. We'll right click. Let's turn it to triangles and points. The points have to be on. There's other ways you can turn them on. So we'll see them turn on. See those points? Those are the surface points that go along with the tin. They correspond with the Kogo points. So if you have bad Kogo points, they'll produce bad surface points initially. But remember, the two can be independent of each other. So we're going to edit this surface point away from this bad Kogo point shot. It's most obviously wrong. So if we go into edit surface with the surface selected and the contextual ribbon, we will modify the point. It wants us to select the point in this viewport in the 3D, so you can also select it here. Since we have this surface on, you can see the points even in this custom view. This sometimes can help. Hit that point, have it selected, hit enter. Now remember, modify points only for the vertical. That's all we're modifying. It really should say vertical edit or something like that. And we're gonna say 170 point or 190.76. Hit enter. It changed the surface to a more valid point. Now notice how it left the survey figure behind. It might be prudent to change that survey figure now. A lot of times in a different workflow, our 2D and 3D stuff would already be fixed. If we're using survey figures, that would remain. So that's fixing that. Another thing you can do is this helps me fix voids in surfaces all the time. Say there's a little void that pops in. There's weird ways they happen. If I modify or move a point, quite literally from one spot to the same spot, it will oftentimes suck in that void if I hit enter. You can also move a point. There's not many reasons you'd want to do this unless you just want to manipulate the surface in some way. Modify this point, or excuse me, modifies in the vertical. User interface. Move point modifies for vertical only. I can say yes, move it here. I move that point. You don't want to do that. You want to keep it with this original Kogo point. That's the accurate data, but I did it anyway, just to show you. And the last couple things is you can add a point. You can add a point right here. You could just call it whatever elevation you want. It'll suck down, or whatever you think it might be. You can also delete out a point. You can do multiple points with a crossing box. So I can delete out all these points, which is a heavy operation. If there's too much data from like LiDAR, I might delete out a bunch of points that are just messy, too much data. On this data, I wouldn't be doing a lot of that, but that is the point commands. So we're going to move on to part 3 of this chapter into page 82, displaying and analyzing surfaces. And while I'm opening up that file, I'm going to go to the book quick. We'll start with the elevation analysis. There's a picture of what we just fixed again. And 82 into 83 as we go into exercise 4.6. I'm going to open up elevation analysis drawing, and let's select one of the contours again on this existing ground tin surface, and Let's go back to the properties again, surface properties, and let's change the surface style to elevation banding. So it divides it up by different elevation bands, so 2D or 2D indoor 3D areas, but we'll do it in 2D over the horizontal. And let's go to the analysis tab first and check out some of the stats in here. Verify that the analysis is on elevations, the type. That's good. There's a lot of different things here, but we're going to stick to elevations. And verify the analysis number of ranges. There's different ways to do this. You can tell it what interval. It has to be every 5 feet, 10 feet, whatever. But I'm going to say number of ranges is verify. We'll leave it at 8 just for this demonstration purposes. And then we'll say run analysis. Go down here, and it automates mathematically, very scientifically, inside of that given surface's statistics, what would make 8 schemes and categories, and they go out to the thousandth of a foot. Similarly, if you did a range interval of every 1 foot, it would make probably a lot more. Okay, you can do this however you want. I might say every 10 feet. Rerun it. It only has 3 color schemes, so you can do it how you want. Make legends, make all kinds of analyses. Let's go back to the original, rerun it again. And let's hit OK just to go back to the drawing. And we see the areas two-dimensionally of where a certain elevation of these 8 different ranges is. And if you hover on the surface, it says elevation 195, or any Civil 3D entity. If you hover on it, certain things will come up. It'll say what it is. There's the elevation. So as it's getting to be hotter colors, it's going downhill. So you can change those colors to what you desire. A lot of times I would think cold would be going downhill, hot would be going uphill, but this is the opposite of that, which is fine. And so you can see the 2D banding. Let's see what it looks like in this 3-dimensional viewport or monospace view. Looks like this. And it wants us to change the style to a different one. Now, if we right click, go to surface properties, and let's change it to elevation banding 3D. Hit OK. It shows the elevation banding, but amongst the tin triangles. So this is kind of cool. Only where the tin is instead of the 2D hatching kind of style. So that's the difference there. And this tells a clear story about the existing shape of the land for the site. So it's shown up here, which is kind of neat. Up in a elevated view, more exaggerated in a way. If I want to orbit around a little, which I'm going to be a little careful to do so I don't crash things, we could do the window here, but we can really see our surface a lot better in this 3D environment through this view and this view. So that's a couple different styles of analyzing elevations, and there's slope analyzations, which we're going to go into next, which is another important feature. I'm going to open that drawing up. So slope analyses would be, you want to see areas where it's really flat to be very buildable. Very steep areas, like in the city of Missoula, for example, over 20% are generally not allowed to be buildable. Certain areas it's such high construction, and to see hydroanalyses of surfaces, various things, you want to have an analysis of where the slopes are the flattest, 0 to 5%. Anything over 20% you want to be defined. So there's a lot of reasons you want to show where the steepest sloped areas to avoid on a land development project or land in general. And there's two ways we can show them. The first is to show slopes as colored ranges, like the one we just saw with the analysis of the elevation, colored ranges in a certain area. Or you can show them, the second way is to show various slope arrows across them that are color coded to indicate what range they're located in. It helps with the color they're given. And it shows the benefit of which exact direction the water would flow in a hydro scenario, and they always point downhill, so they point in the direction the water would flow. So let's look at that. So if we select the surface in this DWG data set, and I'll go right click instead of going to the contextual ribbon up here this time. I'm going to open it up, and on the information tab, we're going to change it to slope banding 3D. In this case, it just wants to show the 3D right away. And on the analysis tab, we're going to check out some things this time too. And we're going to change the analysis type, of course, slopes here. And we're going to click the downward pointing arrow. It doesn't say anything about changing anything, so we're just going to keep the 8 ranges. And here's our mathematical judging on the surface statistics. Any surface could be different in this regard. It puts 8 quick ranges. This is kind of bogus and crazy, but in general, anything above 7.5% slope is this really dark amber, the inferno of Dante right here. So we'll hit OK. And you can see the style populating. And it shows where the different colors are. This is where the steepest slope is, and that Dante's Inferno there. You can also see it in this 3D custom conceptual. Let's move it out a little bit. Conceptual rendering style. You can better see the analysis where the dark is where very likely this is over 8% plus ish, or that 7.5%. That's your not as buildable areas. That's basically the slope analysis. We can just for fun see what it looks like on the other style. We'll go up this direction this time, and we'll change the style to let's see, slope arrows. And we'll say on analysis, we'll say slope arrows as the definition type. And we're going to click this arrow again. We'll hit OK. So this time our style is going to change. It's going to show similar colors. Our tinge still gray, but it's going to show slope arrows. The different darkness reflects the steeper slope. So the darker the arrow, the steeper the slope. The closer to the light blue, the less the slope. So you can see quickly drainage analysis helps you see where the flow is going in the steepest areas. The steepest areas combined with what flow direction in general, showing you some patterns. So that's pretty cool analysis of existing ground surface and where and how to build and get some analysis on. The picture on page 85 is a really good example of how a more senior engineer or someone not necessarily a senior level engineer might see a real drainage divide really quickly, a delineation. You can see where it's almost kind of a ridge on a local site. This helps you see that a lot quicker and more surgical, really. You can kind of see this all tends to want to slope to the south, and this wants to go to the north quickly. This is a good way to analyze a surface for a more skilled engineer, possibly, or someone a little newer that needs a little bit of a refresher on how to better analyze surfaces. So there's some other area analyses of surfaces on page 86. Contours, you can analyze the areas of what contour of a certain integer or not integer areas are, the directions of surface slopes just to see direction. You can make special contours at different weird intervals called a user-defined contour to do basically like saying 92.75. That's an irregular contour. You can make it just to your own needs. Watersheds analysis within a surface where rainfall runoff to a certain point in a certain direction. It shows a way to study how the terrain drains. It shows where the watershed is, and there's some more analysis tools quickly. The water drop tool will show you can pick any point, and it shows a very detailed way of where that said water drop would theoretically flow across the ground to where. A catchment tool is pretty cool. You can click up any point on the surface, and Civil 3D basically draws a closed shape that represents the area that flows to that point. So the entire area on that point you picked, what area surrounding it flows to it, and how big of an area it is. A quick profile is something pretty neat. We'll do those a couple of those right now actually. Let's go to the slope analysis. So if I pick a surface, some of these things will come up. I can do the water drop. So I'll just say, yeah, I want a 2D polyline. I'll leave it on layer 0 for now. Let's just say I pick this point. The water theoretically will flow that way. See that white line that appeared? Let me pick here. Water will flow that way. That theoretical drop. Now I pick close to this ridge. It's showing, oh, this is the point of no return. It goes 3 different spots. So this is a very high point ridge in 3 directions right there. So if I pick a water point right here, the water flows that way on a water drop. Another one is the catchment area. I love using this one. So I pick a point on the surface. I gotta say what I want it to be first. Hit OK. Let me hit this theoretical point right here. It's saying, first let's delete some of these. So I just deleted a bunch of those water drops just to clean this up a little. Let's change the surface properties a little bit. Well, actually, let's leave them on so we can see the flow arrows. I'm going to do a no-no here in a way, but I'm just going to turn on the contours just for now. A lot of times I tell people to leave the Civil 3D styles alone and changes the style that works for them. This is just to demonstrate. So these are in the ribbon and other spots too, but if I pick on a surface, the contextual options come up. I'll pick a catchment area. I'll say, yeah, I want it to be a 2D polyline display where it would discharge to. Let me turn my F3, turn my O snaps off so I don't select all kinds of weird things. Right there. So when I pick this point, it says theoretically everything in this polyline is the catchment. So everything that rainfall falls in this shape would, if I have this point here, whatever I design here, this whole shape would flow into it. That's what a catchment area is saying. That might not be the best option one. You could pick one on more of a low level. So let's draw one again. So this is more of a low zone to the bottom of a ditch or flowing downhill. This area could potentially get this entire catchment area, this entire hydrology, this 2D and/or 3D dimensional area. So theoretically right here, if I had a structure, let's say everything in that theoretical zone could flow into it. So you might not want to put something prone to a flash flood right here in this existing. That's a lot of surface area that could drain to it theoretically. So that's the catchment area tool. Another cool one is the quick profile tool. So you could pick a lot of entities, and I got this polyline selected. You can right click and say quick profile, which is what I'll show you how to do. You can also do it through the surface contextual ribbon. I'll say I want to see the profile vertical of that surface. I'll just say profile view origin. Let's say it's right here. Let's forget about that. The profile, that shows the vertical, and got to pay attention to which direction that polyline goes. Here's the station and the horizontal, and the vertical elevation on the Y. One thing with quick profiles, if you save the drawing, it goes away. So you have to explode it to retain it. Last area of this chapter, which is a fun one, is going to be annotating surfaces. So we're going to add some Civil 3D labels to our surface, and it's the label surfaces DWG, which would be pretty easy, I think, for us at this point. Surfaces, basically, as we've learned, they tell a story of the shape of a piece of land. There's lots that you can analyze in them to do better designs, to get a view of how the existing land works. One of the ways to help tell that story, as we're seeing in the book, is to annotate the surface with contour labels, spot labels. So we have our drawing open, and the top right viewport it wants us to go to in the north of the project is near a location where the magenta center line here, it's saying, meets the center line of the existing road. The magenta center line is going to be the center, let's say, of our proposed or new road. So our task is to label the elevation of the existing road. It's saying where these two center lines meet. So basically, we're going to get our contextual ribbon up by selecting the surface. There's obviously we've been learning a lot of ways to get here. We're going to learn this way first, and we're going to say add labels, and we're going to say add surface labels. Okay, we'll show you why in a second. If I go to add surface labels, it opens up this entire dialog box that stays open, which I love. And I go to my Civil 3D entity. There's many, from notes all the way to catchment survey figures. I'm going to stay on surfaces. It's our first experience with this in a bit. And I'm going to say at this point spot elevation. And there's styles that come now. So we've already gone a little deeper in here, and we're going to verify the spot elevation label style is, not the marker style, excuse me, is elevation only existing. You'll see standard in here a lot. That's in almost every Civil 3D style out of the box. It's a placeholder. You can delete them out if you get crafty, but you'll have your custom styles here in your company. We'll leave this for now. You can put many different nodes on it, but we'll keep spot elevation. Let's say add. It's saying select a point. Always pay attention to your command bar. It tells you what to do oftentimes. Let's turn back on our O-snaps and our tool tray, and I want it to pick endpoint O-snap, AutoCAD snap, pick there. It adds the surface label, spot elevation label of 189.8 feet in decimal feet of hundredths. It's very common in civil surveying, is hundredths of a foot. So there we go. Saying at this point we're going to pan to the south where the road hits a 90-degree angle right here, and we want to do some research there, and there's steep slopes you can see on this side and this side, all the sides. Kind of a tough place to build a road, really, but we want to measure and label the slope in this area to determine whether, let's say, homes can be built. It says, or guardrails will need to be worked in for the road. So this time we're going to remain in this. You can also get to it through the annotate tab and add labels this way as well. We got to it through picking the surface contextually and opening up it this way. Contextual ribbons are blue in this case in Civil 2022. So we still have it open. Our add labels. We're going to go to, in this case, slope labels. And we're going to verify the slope label style is set to % existing. You'll see what that means in a minute. It's basically how it's going to display. And let's go a little too far to the left there. Say add. And we're going to accept it's going to be a 1-point direction, not a 2-point. 2-point lets us select both points. 1-point will go perpendicular to the contours no matter where you put it. So a lot of times it's good because it's automatic, but sometimes it can be unwieldy. So we'll say 1-point if you have that one showed in that, if you have your dynamic input on, it'll show on the screen like that. I'm not going to get too crazy. I'm just going to pick some points south of the road showing the slope. And let's pick a few of them. Why not? Let's go to the north of the road, showing what the percentage degree, what your slope is. So it's a little steep in some spots. It's flat on this knoll here. If you go right here, it's going to be really flat, almost 0. So I'm just adding too many of them, really. And you pick on one of these labels. Basically, it's 1.1, so you can just move its location with that grip right there. And see, it always stays perpendicular to the contour. That's because that's what it wants to do. Now, if we did a 2.1, you're making it a little bit fictitious. You select its 2 points where you want it to go. We'll say add, go to 2-point instead. It wants to default to 1-point, which is great. Usually that's what you want. Let's go to 1-point or 2-point. Let's just force it to pick there, and we'll do a second pick here, making a really long one. That's -6 downhill slope there. Negative always means it's going in the downhill direction, and these 1-pointers always default in the downhill direction because that's usually where we want to see and where we want to see water flow. That's why that happens. Now these 2.1s, you can totally flip and go to a different direction by dragging. There's 3 grips instead of 1. You can make them do other things. This goes in an uphill direction. It's positive. It's no longer -6. So these ones you can move all around, but they're fictitious in the way that you can kind of suit them to your needs, so it can go in an exact direction. It doesn't have to be perpendicular to contours, as you can see, like my 1.1s are. They can go any crisscrossing direction. So that's it on those. We're going to end the chapter with adding some contour labels, which you've seen on any crazy USGS topographic map. We're going to end with adding our contour labels. So let's go down to that label type, Civil 3D. We're going to say contour multiple in this case. And we're going to verify that we have existing major contours on and existing minor contours on. And we'll leave this one alone here for now. Say add. And I'm not going to go specific to where they exactly want in the book. Let's just pick a spot. And you can get really interesting. I'm going to turn my OSnap off. That's going to be a pain in my ass a lot of times with this stuff. We'll go pick where we want. And I'm going to turn off my ortho in polar tracking so that I can go at any angle I want, which with these is handy. And you'll see why in a second. I'm going to zigzag through these so they don't overlap exactly where I want. Keep picking. They're small enough right now at this 1 inch equals 50 foot scale that they all can fit, and the style is small enough where they do okay. So I'm just going to keep drawing my contour labels. It says the exact contour in integer, nearest foot. It's usually what contours are. We learn user-defined contours usually are to odd integers and fractions. I can always pick outside of the surface and continue on and move back onto it. So you can keep doing this. Now your contour labels need to be dialed in to be the right size, as a lot of your CAD standards do. Depending on what company you work at, that's pretty critical. Otherwise you're going to be fighting those and editing them on every job you're on, which I've had to do in many places. It's not that fun, but if they're dialed in, this part's pretty easy and not bad. So there we go. We added our contour labels. And that's about it on this chapter. Now you know how to better understand the role of surfaces in land development, how to create them from survey data, how to do some basic edits, and some more advanced ones, how to analyze surfaces with elevations and slopes, and finally in the end, the fourth part, how to better label them.